Hello students, welcome back to my channel JPPHYSICS. In today's lecture, we are going to consider the next derivation from that rotational dynamics. It is parallel axis theorem. Parallel axis theorem. Okay, see, this question will be for 4 marks. In that question, they will ask state and prove parallel axis theorem. Simply, they can ask explain parallel axis theorem. For both questions, you have to write the same answer. But first, keep it in mind that you have to write the correct statement for parallel axis theorem. What is the statement for parallel axis theorem? Parallel axis theorem state that moment of inertia of a body about any axis is equal to sum of the moment of inertia about an axis passing through the center of mass parallel to the given axis and product of mass of the body and square of the distance between that given two axes, means given axis and the axis passing through the center of mass. So we have to write this statement correctly first. You will get 1 mark for that and another remaining 3 marks for that derivation and diagram. Okay, so what will be the diagram? Let us see first. Let's start our derivation by diagram. See, if I consider this is one diagram, you know that parallel axis theorem can apply for any shape of the body. Means it is not different, or it doesn't have any different meaning when the body shape of the body is different. So this theorem can be applicable for any shape of body or body of any shape. Not like that perpendicular axis theorem, because it is only applicable for plane sheet. Correct? So this parallel axis theorem, it is applicable for body of any shape. So this is one body which having mass capital M. If I consider this body having mass capital M, let us consider this as a center of mass. Okay, this point as a center of mass, and we have to find out the moment of inertia about an axis passing through this point O, which can be any arbitrary point of that body. So I will consider this axis which is passing through this body. Correct? Okay. So this point as O. This point is center of mass. So another axis we have to consider which is passing through that point C. Okay. So this is point C, that is center of mass, and this point O is point through which one axis is passing. About that axis body is rotating. We have to find out the moment of inertia about an axis passing through this point O. See, I will repeat that statement so you will get the idea. See, we have to find out the moment of inertia about this point. Then what will be the statement? See, the moment of inertia of a body about any axis is equal to the moment of inertia of the body about an axis passing through the center of mass, and product of mass of the whole body and square of the distance between them. If I consider the distance between them as h, distance between these two parallel axes, if I consider as h, then what will be the statement? That is IO is equal to, that is moment of inertia of the body about point O, is equal to IC, that is moment of inertia of the body about an axis passing through the center of mass and parallel to the given axis. Means this axis must be parallel to the given axis. Okay. Okay. So I naught is equal to IC plus, it is the sum of moment of inertia about an axis passing through the center of mass and product of the mass of whole body and square of the distance between that two parallel axes. Means that product, mass of whole body and square of the distance between them. We have to prove this. I naught is equal to IC plus mh square. I naught is the moment of inertia of the body about an axis passing through the point O, and IC is the moment of inertia of the body about an axis passing through the center of mass. So, if I consider one small mass element dm which is present at point P at distance OP from this given point and at distance CP from this center of mass. So what I have to do, I have to connect this 2 points and extend them and make the perpendicular here. I will write this dm aside. See, this is mass dm which is present at this point P. What construction you have to do? You have to consider one point P where we are going to consider one small mass element of this body as a dm, correct, which is present at distance OP from this point O and CP from center of mass. So what is the construction? We have to join this OP, we have to join this CP, and also we have to extend this OC up to point D. Up to point D. Okay. Now this will be 90-degree angle because I have made the perpendicular PD up to this point D. So this is the construction, or this is the required diagram for the derivation. So you have to first understand this diagram also, because we are going to use the formula for moment of inertia here. What is the basic formula for moment of inertia? It is nothing but mr square. That is mass of the body and distance of that body or that mass from the that axis of rotation. Correct? If I consider one ring, and ring is rotating about its own axis passing through the center and perpendicular to its plane. So what we consider? We consider that radius. Why radius? Because all the mass distribution at distance r from the center. Correct? So mass is distributed at distance r, and that moment of inertia of ring we have taken as a mr square. dm. Correct? dmr square. Summation of that dm will be mass of whole ring. Therefore, moment of inertia will be mr square. We have seen that, correct? You have already studied that. Only we are taking the review, or we are making the revision of these derivations at this time. Okay. Now, this is the point about which we have to find out the moment of inertia. If I consider this mass dm from this axis of rotation, the distance will be OP. Then what will be formula for moment of inertia about this axis? By formula, what I can write? See, I naught is equal to integration of OP square into dm. Why integration? See, this body having continuous mass distribution, correct? See, dm. These all small elemental masses are distributed continuously in this body. So we can't directly the moment of inertia of this body about this axis, because this body having any shape. So I have to consider each and every mass and that distance of mass from this axis of rotation. I have considered that mass here at point P, which having the distance OP. So I have to take the integration of OP square dm, mr square. The mass is dm and distance is OP. Therefore, dm into OP square. I have to take the integration. It is only for one mass. I have to consider whole body. Therefore, I have taken the integration. Let the equation number as 1. Now, what will be IC? IC, that is moment of inertia of this mass dm about center of mass, that is about an axis passing through the center of mass. That will be Cp square into dm. Cp, because this is the distance Cp from center of mass, that is axis passing through the center of mass. From this point C, the distance of this mass element dm, it is Cp. Therefore, what will be the formula? Ic is equal to integration Cp square into dm. Let this equation as equation number 2. Now, if you write these two equations correctly, next derivation is very easy because you have to use only Pythagoras theorem, right? So here there are two right angle triangles, see, ODP and another it is CDP, right? Initially we will consider triangle ODP. In right angle triangle, from figure, in right angle triangle ODP, what you can write? Hypotenuse square, that is OP square, is equal to OD square plus PD square. Therefore, OD square plus PD whole square. But what is OD? See here. What is OD? OD is nothing but OC plus CD. So I will write OC plus CD whole square plus PD square. Now split this A plus B whole square by using that formula identity. What will be that? OC square plus CD square plus 2OC into CD. Right one? A square plus B square plus 2AB. Therefore, OC square plus CD square plus 2OC into CD. Plus this PD square will be as it is. This OP square, this is the value of OP square. Let this equation as equation number 3. Now, another right angle triangle is here. There is a CDP. In that right angle triangle, CDP, what we can write? See, CP will be the hypotenuse. Therefore, CP square is equal to CD square plus PD square, right? CD square plus PD square. Now, let this equation as 4. Here there is a PD square. Here is also PD square. If I put the value of PD square from this equation number 4, what I can write? See, PD square is equal to what? CP square minus CD square. CP square minus CD square. So, take this value and put in equation number 3. So, put the value of PD square in equation number 3 by putting value of PD square in equation number 3. Equation number 3, we will get, see, OP square as it is equal to OC square plus CD square plus 2OC into CD. What is PD square here? CP square minus CD square plus CP square minus CD square. Now here also CD square, here also minus CD square. Therefore, this CD square will get cancelled with this. What will remains? OP square is equal to OC square plus 2OC CD plus CP square. Equation number 5. Now, put this equation number 5 in equation number 1. See here there is OP square and we have find out the value of OP square. So put equation 5 in equation 1. What we will get? I naught is equal to OP square. What is OP square? OP square is nothing but OC square plus 2OC into CD plus CP square into what? Into DM. Now separate the terms. Okay, so what will OC square into DM plus integration 2OC CD into DM plus CP square into DM. Now OC square. What is OC square here? OC, it is H. Distance between two parallel axis, that is h square. Therefore, and this h square is constant, it is not going to change. So, I will take it outside, therefore h square integration dm plus. Now, this term and this explanation is very important in case of a parallel axis theorem. Up to this point, you will write the derivation by using the Pythagoras theorem and all. But here, when you are going to write the explanation for this term, you have to remember that, see, 2OC, 2 it is constant, OC it is h, it is also constant. So, I can write 2h, but this integration of CD dm, if you think about that, see, CD is what? CD is the distance from center of mass. And by the definition of center of mass, it is clear that integration of CD dm will be 0. See, I can consider this CD and similar way, I will consider same point on this left side. On this downward, upward, left, right, all this side, that distribution, that distance will be same if I consider all the points. And if we know the definition for that center of mass, that is mass distribution, the point at which whole mass of the body is supposed to be concentrated and all. So in NLM also you have seen that center of mass, velocity of center of mass, position of center of mass, all that things you have studied in NLM in 11th standard. So you have to write here one explanation that according to definition of center of mass, this integration of CD into dm will be equal to 0. You have to write that sentence only, but it is very important. If you not write that sentence, why that term becomes 0, you are not going to write that reason for that. Okay, so you will not get the marks. That marks will get cut here. Okay, so you have to write the explanation for this term. It is very important. Okay, I will write that. But first I will write this term. See, integration of Cp square dm. What is that integration of Cp square dm? Here, equation number 2. What is that integration of Cp square dm? It is nothing but Ic. So I will put that value Ic. Here you have to explain that according to definition of center of mass, integration CD dm is equal to 0. You have to write this sentence. It is very important. According to definition of center of mass, integration of CD dm is equal to 0. Therefore, I naught is equal to, see, h square as it is. What is integration of dm? dm, that is summation of all that continuous distribution of mass, that will be mass of whole body. And we have considered that mass of whole body as capital M. Here also you have to write this arrow. Okay. So capital M will be the mass of whole body, and this term becomes 0, therefore remaining will be only Ic. So what I can write, I naught is equal to Ic plus mh square, hence the proof. See, we have to prove that I naught is equal to Ic plus mh square. I naught is equal to Ic plus mh square. You will get 4 marks for this, but you have to write this sentence. It is very important. Very important. Because this term becomes 0, and that after that only we get the proof. That is, I naught is equal to Ic plus mh square. Means in this derivation, first you have to write the statement. What is that statement? Moment of inertia of body about any axis is sum of the moment of inertia of an body about an axis passing through the center of mass and parallel to the given axis, and product of mass of whole body and square of the distance between them. That is, I naught is equal to Ic plus mh square, and we have to prove this one, I naught is equal to Ic plus mh square. For that, another means next part, it is very easy, that you have to consider only the 2 right angle triangles and Pythagoras theorem, and putting the value of that PD square from this second right angle triangle you will get your solution. But at that time, again I repeat, you have to write the explanation for this term, that is 2h integration of CDDM. This integration CDDM, the CD distance is from the center of mass. Okay, so according to definition of center of mass, this integration CD into dm will become 0. Therefore, I naught will be equal to h square integration of dm plus IC, and integration of dm is nothing but sum of all the elemental mass of that body. Therefore, that will be whole body mass, that is mass of whole body, that is capital M. Therefore, I naught is equal to ms square plus IC. You understood the derivation? It is very, very important derivation. Number of times it is asked for exam. So, prepare it, and if any doubt regarding this derivation or also another derivation, you can comment in comment box. So I will get that question, I will give you the answer of that question for you. I will make that derivation for you. If any doubts, ask me, I will give the answer. Okay, if you like the channel, if you like my video, like the channel, share and subscribe it. Please press the bell icon. Again I repeat, please press the bell icon so you will get the notification for next lecture, because again in next lecture I am going to make the derivation for that conservation of angular momentum and kinetic energy of rolling body. Okay, thank you.